So I just wanted to watch my favorite YouTube channel, but Elon turned off my Starlink internet. Luckily, I can play the T-Rex game in my Chrome browser. Being one of the most played games in the world, I think it deserves some more credit. Alright, you know what this video is about. Roll the intro. So in 2022, I made this real-life T-Rex game for a school project. It's definitely one of the coolest things I've ever made, yet it's been sitting in a dark closet somewhere in my old secondary school. So let's fix it, and in the meantime I'll show you some nifty electronics and mechanisms that make it all function. So this is the basic idea. We have a little T-Rex that can jump up and down in the air with some kind of servo mechanism. Just like in the original game, the background moves along with little cacti on it that you can jump over. The way I decided to do this is with a rotating belt on which the background is printed. A very elegant solution, but it brings a few problems with it. First of all, limited background space. There's only so many cacti that fit on this belt, so if we want to make the levels progressively harder, we'll have to find a way to change the speed at which the belt is rotating. And then of course the biggest challenge is detecting when the T-Rex is making contact with a cactus, because there's no actual physical contact. Anyway, let's take a look at the machine and see if it survived 3 years of torture. So we have the main control panel, the electronics, and of course the display. This really is the component that does all the magic. As you can see, it consists out of quite a few parts, so let's assemble this thing. The belt is kept in place by two pulleys, one freely rotating pulley and one driven pulley. With the help of some bearings, they each rotate on these two big M6 bolts. Next, a 3D printed middle section can be inserted and screwed in place. And now it's time for some electronics. First of all, the 12-volt DC motor that's used for the belt mechanism. This one has an internal gear reduction of 1 to 100. The motor is screwed to these rails to accommodate for different gear sizes. I put on this top plate a bit too early because we first gotta install some very important electronics. This is the sensor responsible for cactus detection. The LED module shines visible light through a thin slit. On the other side we have an LDR sensor which basically measures light intensity. So when we place these opposite of each other, we can essentially measure if there's something in between both sides. If we now put slits in the belt, we have a digital value that gives us the exact position of each cactus. So let's say the sensor is located here. If the T-Rex touches a cactus, we want the sensor to give a digital value of 1, so we make a slot. If the T-Rex is past the cactus, we want the value to become 0 again, so we end the slot. Now we do this for every cactus, and that's basically it. Installing this sensor module requires just a few more bolts. After installing the top plate, we only have to do one more thing, and that's of course installing the T-Rex itself. The T-Rex moves up and down with a very simple rack and pinion system. For this we don't need any additional obstacle detection sensors, because of course we use a servo motor that has a built-in angle sensor. And that's the final piece of the display. After installing this, we can move on to the control panel. The control panel itself is pretty simple. We have 4 LEDs that indicate the difficulty of the game mode. As you can see, one of the LED covers broke, but fortunately that's an easy fix. On the right we have a joystick that controls the T-Rex's movement and allows you to switch between game modes. Okay, so with the interface installed, I can show you the rest of the electronics. As you can probably tell, the system is directly connected to 230 volts AC. The internal power supply lowers this to 5 volt DC for the Arduino and other electronics. This H-bridge controls the motor speed, and these are the LEDs and the joystick from the backside. We have a little buck converter for the 12 volt motor and a little circuit for the buzzer and the sensor connection. So now all we need to do is connect the screen with these JST connectors and tension the belt. After a small test, we can install some finishing touches, like for example a little frame that goes around the screen, and of course the backplate to hide the electronics and prevent idiots from getting electrocuted. So with the hardware done, it's time to explain how the game actually works. Okay, so when you start up the game, all the high scores are reset. By toggling the joystick left or right, you can choose the difficulty of the game, which is indicated by the LEDs. For each difficulty, these variables determine things like the background speed, jump speed, etc. Obviously, the higher the difficulty, the faster everything will go. So let's now start a game by clicking the joystick once. So first, the T-Rex will go to a safe starting position. It does that by turning the belt backwards until it detects a cactus and then turning forward a little bit. This ensures you'll never start on or right before a cactus. And now the game can actually begin. You jump by pushing the joystick up. The longer you play, the faster the background will move. Your score is measured in time, and when you beat the high score, you hear this. Okay, we'll do that one more time. I also added the digital value in the bottom left corner. Again, if there's a slit, the sensor value will be 1. If there's no slit, the sensor value will be 0. So if the sensor value is 1 and the T-Rex isn't above a certain height, this means that there's contact with the cactus and it's game over. Okay, I hope I was able to explain this somewhat decently. If you want to make it yourself, the files are available in the description. Maybe one day I'll make a fully 3D printed version of this that's easier to assemble, but we'll see. If you have any questions, make sure to let me know in the comments. YouTube really screwed me on my previous video, so if you made it here, please give me a thumbs up. Till next time, bye.